Okay, let me show you some additional methods of solving quadratics. The next method is if you can get something being squared by itself on one side, you can square root both sides, and that's called the square root method. So here I have another quadratic, and if you're not convinced of that, you could multiply that out and you would see that the highest power is going to be x squared. But the thing that I like about this quadratic is that I can get the squared part alone. So I add 2 to both sides and I get 2x minus 3, quantity squared, equals 5. And then I'm going to square root both sides, and I write plus or minus when I take the square root. So I get 2x minus 3 equals plus or minus square root of 5. And then I'm going to add 3 to both sides, and I get 2x equals 3 plus or minus root 5. Some of you might have thought I was going to put an 8 there, but you can't do that because 5 is under a square root and 3 is not. And we don't add square roots like that. And then the last thing I want to do, I'm going to divide everything by 2. So I get x equals 3 plus or minus root 5 over 2. If you want to separate it into two different things here, you can do that. If you want to make it two different fractions, you'd get 3/2 plus or minus root 5 over 2. Or you can leave it like that. It's okay either way. Another example that I want to do is I want to solve by completing the square. And to do that, I have to create a perfect square trinomial. So here I have a quadratic. And before I can create a perfect square trinomial, I don't want anything in front of the x squared. So I notice that if I divide everything by 2, that gets rid of the x squared. Now, if you can't evenly divide everything by the number in front of the x squared, maybe you shouldn't complete the square. You might want to do it another way. So I've got the thing out from the front of the x squared. And now I'm going to add 8 to both sides to give myself space to complete the square. Okay, so now I'm ready to complete the square. We are going to create a perfect square trinomial. You know, when you were in kindergarten, you made macaroni pictures, but now in high school, we're making things that are even cooler. We're making perfect square trinomials. So if you remember, the way you make a perfect square trinomial, you look at the x term, and you do half of b, square b, add b. So off to the side here, I do half of b, so I divide it by 2. Whoops. Almost divided it by half there. So divide the 2 by 2 and you get 1. And then you square the 1 and you get 1. And that is what you're going to add. And you have to balance the scales by adding it to both sides. So now I have x squared plus 2x plus 1 equals 9. And because I did half b square b add b, I have forced this thing on the left to be a perfect square trinomial. And when you have a perfect square trinomial, you can square root the outside terms and bring down the sign in the middle and rewrite it as this binomial squared. And if you're wondering what happened, you know, some people say, what happened to that 2x in the middle? Well, if you expand this and FOIL it back out, it will reappear. It's just hiding, but it's not gone. And now I'm going to square root both sides. And when I square root, remember I get plus or minus. So I have x plus 1 equals plus or minus square root of 9, which is 3. And that gives me x plus 1 equals 3. Or x plus 1 equals negative 3. Don't just subtract 1 and say your answer is plus or minus 2, because that's not how it works. The first one, when you subtract 1, you actually do get 2. But here, if you subtract 1 from both sides, negative 3 minus 1 gives you negative 4. Now this one, some of you might have noticed, could have been factored as well. And probably if I had one that I could factor, I would factor. But I just wanted to show you how to use the completing the square method, because you're going to use this all year. When you get to circles and conic sections, you're going to have to complete the square. So it's probably a pretty good technique to know. Alright? Now the last thing we're going to do is, some very nice, intelligent person once, a long time ago, completed the square on this equation without taking the letters out. They kept the letters in there, and you guys all actually have the ability to do that. You may not believe it, but you do. And if you were to complete the square like I did above without taking letters out and using the letters, this is the formula that you would get. So anytime you can write a quadratic formula in standard form, you can solve it in this way. And depending on what the thing under the square root part is, you may have no solutions, or one solution, or two solutions. So let's solve this particular problem. I have to get it in standard form. So I'm going to subtract 6 from both sides. And then I can do quadratic formulas. So it's negative b plus or minus square root of b squared. And by the way, if this had a negative in front of the 4, make sure you square the negative. So put that in parentheses if there's a negative in front of the b term. Okay, there's not for this, so I don't have to worry about it, but just be careful. So minus 4 times a times c, and also notice there is a negative in front of the c term, so make sure you bring that along. So if there's negatives in front of the b, make sure you square the negative so that becomes positive. And if there's a negative in front of the c, after you move everything over, make sure you keep that negative there. And then this is over 2a. And I just simplify, a few steps at a time. So on the inside I get 16, and this is going to be 12 times 6. I believe that's going to be 72, and it's going to be positive 72, and then over 6. And then that gives me negative 4 plus or minus square root, let's see, 16 plus 72, that's going to be 80, 82, 88, looks like, right? Over 6. And then, I'm kind of running out of room here, so let me move this over. You can take that 88 and split it up. So 88 you can rewrite as, well, let's see. I guess I could rewrite that as 8 times 11. Probably a better way to do that would be 4 times 22, though, because 4 is a perfect square, and I can move that out. So I do that. Still running out of room here. And when I do that, I get negative 4 plus or minus 2 root 22 over 6. I just square rooted the 4 and brought it out. And then if I divide everything by 2, I get negative 2 now, plus or minus root 22 over 3. So these are my two answers. You can leave them like that, or you can put them in a decimal form, or you could even write them as two separate fractions here. So negative 2/3 plus or minus root 22 over 3. And that's all you have to do. Okay, so hopefully you are now experts in many, many ways and many methods of solving quadratics, and I'll talk to you again soon.